Hi, everyone. My name is Svec, and the title of my talk is Observe and Response of Halibut to Fishing Gear. So to start off this talk, there is a very common issue in the fisheries world that can hurt fish populations, cause fishery closures, and really affect people's livelihoods that depend on fisheries. And this is the issue of bycatch, which could then lead to overfishing. And bycatch, for those of you who don't know, is a term defined as discarded catch of marine species, as well as unobserved mortality due to these direct encounters with fishing vessels and fishing gear. So just to give you a quick example, let's say you go out on a boat fishing specifically for halibut, but in the process, you catch a bunch of other fish that you're not allowed to keep. So you just have to end up throwing them overboard. And that's just one example of what it looks like. So there are many ways to alleviate these bycatch numbers. And one approach is studying fish behavior and how they interact with the current types of fishing gear that we're using. Because if we could better understand a fish's anti-predatory response and the external factors that influence their behavior, like illumination and temperature and so on, we can make the proper modifications to our current fishing gear to better complement the targeted species behavior. So this will result in more catch of the fish we do want and less catch of the fish we don't want. But the challenge is, how can we study this behavior in their natural environment? So NOAA Fisheries, more specifically the green sturgeon team I interned with, has just developed this underwater video analysis project that can address this challenge. And the first step is just gathering data to see these types of behaviors. And this leads to my research question, which asks, how do California halibut fish gear responses differ between a light touch trawl system, which is modified, and a traditional trawl system? So diagram 1 here shows a typical bottom trawl gear setup, which is hauled along the ocean floor to herd and capture a targeted species. And a traditional trawl will, on their foot rope, they incorporate these large, round, weighted rubber rollers that roll along the ocean floor. And a light touch trawl system, which is right over here, here's the foot rope, incorporates these lighter chain loops that are intended to reduce ecological damage as well as increase escapement of non-targeted species. So like a crab or other fish can escape going under or through those chain loops. And I interned with NOAA Fisheries, and it was a virtual internship, and there was a lot of trial and error, and there was a lot of detailed work involved. But just to make it super simplified for everyone here listening, I would watch video on a daily basis, about 3 hours at least a day, and I would record all the behavioral data and more on all species coming into view of the camera. And by the end of my internship, I would synthesize the data specifically for California halibut to see if there was any patterns in behavior among these two trawl types or not. What's unfortunate, but also very normal with this kind of work, is that it's not guaranteed you'll have enough observations or data to draw statistically significant conclusions. And that was one of my main concerns, but my mentors kept telling me it's really normal, just keep doing what you're doing, just keep it up. And so by the end of my internship, me and my faculty mentor, we looked at the data and we realized there wasn't really enough to do anything with it. But given the small sample size that we had, here's a horizontal bar graph showing the behavioral categories observed among California halibut. And the blue represents observations for the traditional trawl. The red is the light touch trawl. And the first thing you notice is a lot more blue than red. And also, there's not really a main takeaway and difference between behaviors of these trawl systems, but that could mainly be due to a lack of observations. And the main reason why there was a lack of observations was because of technical and environmental challenges. So half the video files for the light touch trawl system we couldn't even use because the camera light, it went out. So it was just pitch dark. It couldn't record anything. And even with that camera light, just the natural dark, murky water of the West Coast, paired along with sediment that is being spiraled up in the camera view from this bottom trawl gear setup, made it really hard to see all species coming into the net and just being able to identify an observation down to its species. So the graph here right below the first one shows visibility categories I had to enter for each observation made. And out of 1,244 observations, 961 were considered low, 90 were moderate, and 8 were good. So the pictures below it, this one here on the left, just giving you an idea of what the fish look like out of water, are some of the local flatfish species where these tows were being conducted, while the two pictures to the right show California halibut underwater through the underwater video. And those are some of the best quality pictures that I've seen through my internship experience. And this just goes to show it's really hard to identify a species using underwater video compared to actually holding a fish in your hands in broad daylight. And this is because fish on video, they only give you a glimpse of their body and they can swim past the camera most of the time in half a second or less. And even when you pause the video, they come up really blurry. So this work is relatively new, but it's only been getting better and better through trial and error and improved technology. Underwater video analysis potential, it's there. It's been shown in past studies, and this can further improve knowledge on California halibut, but not just them, also all marine species observed, and we can then use that data to answer a multitude of fisheries management questions. So for the next steps, I simply suggest the development of this project to continue developing and to really research ways to address the challenges of visibility. I would like to give a huge thanks to my site supervisors, Susan Wang, Benson, and Christine from CDFW, and my faculty mentor, Andre Punt. Without them, this would have been a totally difficult and different experience. So thank you.